If we've got a simple circuit with a battery with an internal resistance connected in series to a load resistor, capital R, we know that the power output of the battery is partially spent in powering whatever device is represented by the load resistor and partially spent in heating up the battery due to its own internal resistance. The question we now ask is, what value must the load resistor have to maximize the component of power delivered to the load resistor itself? We start with our expression for the EMF of the battery in terms of the load resistance and the internal resistance of the battery. And we know this implies a current, which is just equal to the EMF of the battery divided by the total resistance of this circuit. The power output of the battery consists of two parts, the first being the power consumed by the load resistor, the second part being the power consumed by the battery. In other words, the rate at which energy is consumed to heat up the battery or increase the internal energy of the battery. In the extreme case where we choose a very large load resistance, we make the current very small. Hence, the power delivered to our load resistor, if the current is extremely small, is almost zero. On the other extreme, if we make the load resistor very small, we reduce its ability to utilize electric potential energy and turn it into internal energy, which means by definition that it cannot consume any power, which means most of the power of the battery now just goes into heating up the battery itself. The question now becomes, what value of the load resistance, capital R, will optimize the component of the power delivered to the load resistor itself? Using the expression for the current in the circuit, we can write the power delivered to the load resistor as the square of the EMF of the battery times the load resistor divided by the square of the total resistance of the circuit. If we take the derivative of this expression with respect to the load resistor itself and set this to 0, we find that value for the load resistor, which maximizes the component of the power delivered to the load resistor itself. You can prove for yourself that this value of the load resistor is just equals to the internal resistance of the battery.